Have you ever wondered why you don't just float away from the surface of the Earth into space? Of course you probably know, it's because of gravity. And we know from Einstein how it works, but the deeper question is, well, why does gravity work at all? In this video, we're diving into an incredible mystery. Why does gravity exist? And more specifically, why does matter bend space-time? We'll explore how our understanding of gravity evolved, what space-time actually is, and why matter warps it. By the end, you'll see not only how, but also why this phenomenon shapes our universe in truly mind-blowing ways. For hundreds of years, we understood gravity through Isaac Newton's ideas. He said gravity is a force pulling objects with mass together, like why an apple falls from a tree, or when planets circle the sun. Newton's laws worked amazingly well, but they couldn't explain everything. For example, Mercury's orbit shifted slightly more than Newton predicted, and no one knew why. Then, in 1915, Albert Einstein came along with his theory of general relativity. He said gravity isn't a force, it's actually what happens when matter bends space-time. Massive things like stars or planets curve the space and time around them, and then those and other objects follow those curves. Einstein's idea explained Mercury's orbit perfectly and opened up a whole new way to see the universe. So what is space-time exactly? Well, it's the four-dimensional mix of space and time. This means start with the three spatial dimensions we're familiar with, such as up, down, left, right, back and forward. Then we add in time, and this makes our four total dimensions, known as space-time. In Einstein's theory, matter and energy bend this space-time fabric. Picture a heavy ball sinking into a stretched rubber sheet, making a dip that pulls smaller things toward it. That's kind of how gravity works, but space-time is trickier because it's four-dimensional, not flat like the sheet. When a planet or star sits in space-time, it warps it, and that warping guides how things move, like how the moon follows the curve Earth makes. It's wild to think about, but it's how the universe operates. So here's the big question. Why does matter bend space-time? In general relativity, it's just a basic rule of the universe, like how magnets attract metal. In other words, matter and energy curve space-time, and that's that. The theory really doesn't dig deeper into why, but scientists, and I too, aren't satisfied with accepting that's just how it is. They're exploring ideas like quantum gravity, string theory, and others, trying to connect Einstein's work with the tiny world of quantum mechanics. Someday those theories might reveal a deeper reason why matter is able to bend space-time, but for now they are still in the works and represent some of physics' greatest mysteries. With that, let's talk about the theory of quantum gravity, meaning it could in fact be the reason why gravity works the way it does. But this one's a little trickier. Picture a jigsaw puzzle with two big pieces. General relativity, which explains huge things like planets, stars, and galaxies. And then quantum mechanics, which explains super small things like atoms, electrons, and quarks. The problem? These two pieces don't fit together. They don't agree on how gravity works when things get really, really small. Scientists think quantum gravity might be the missing puzzle piece that connects them. And if they find it, it could tell us why matter bends space-time by showing how gravity works in the tiny world of particles. Maybe matter bends space-time because of something super small, like tiny bits of energy or rules we can't see yet. It's like trying to figure out how a magic trick works by looking at the smallest details. Scientists are still searching for this piece, and when they find it, it could change everything. Now, let's check out string theory, which is wild and fun. And this one too could be another reason why gravity works. Imagine that everything in the universe, every speck of matter, every force is actually made of teeny tiny strings like super small rubber bands. These strings wiggle and vibrate in different ways, and each wiggle makes something different. One vibration might make a particle like an electron, another might make gravity. In string theory, matter bends space-time because these strings are connected in a special way that creates the pull of gravity. It's like plucking a guitar string. Each pluck makes a different note, and in the universe, each vibration makes a different part of reality, including the bending of space-time. And so matter might bend space-time because of how these tiny strings are playing together. Pretty cool, right? Here's one more, loop quantum gravity. Think of space-time as a giant pile of Lego bricks, but super tiny ones, smaller than anything we can see. In this idea, space-time isn't smooth like a trampoline. It's made of little loops or chunks that snap together like Lego pieces. Matter bends space-time because it squishes or twists these loops when it sits on them, kind of like pushing up against a Lego tower and making it lean. Scientists think these loops might be the building blocks of the universe, and when matter changes them, it creates the curves we call gravity. When matter bends space-time, it does some crazy things. One is time dilation. This means time slows down near heavy objects. Meaning if you hung out near a black hole, time would crawl for you compared to someone far away. We've actually measured this. For example, clocks in space tick a bit faster than on Earth because gravity's weaker way up there. It's why GPS satellites adjust their clocks to stay accurate. Another effect is the universe expanding. Einstein's equations show space-time can stretch, and we see galaxies drifting apart, proving the universe is growing. Plus, curved space-time makes wild ideas like wormholes possible, which are thought to be tunnels linking far-off places. I hope now you can see how space-time's bend affects everything from the cosmos down to daily tech. We know for sure that matter bends space-time because we've seen it in action. In 1919, during a solar eclipse, scientists watched starlight bend around the sun. Just as Einstein predicted. That was huge proof. Then, in 2015, the LIGO experiment caught gravitational waves, ripples in space-time from colliding black holes, which is a little bit like hearing the universe vibrate. We also see space-time curving near black holes, where gravity is so strong, it warps how things move. These discoveries back up general relativity and show us matter really does shape space-time. So why does matter bend space-time? It's a core part of Einstein's general relativity. Whether it's due to quantum gravity or something else, we know matter curves space-time, and that's what we feel as gravity. We've seen it in bent light, rippling waves, and more. Though the deepest why is still a puzzle scientists are chasing. It's a journey that keeps us looking to unlock secrets of the universe. If you loved this cosmic trip, hit that like button, subscribe for more space adventures, and drop a comment with your thoughts or questions about space-time. Thanks for watching, and keep gazing at the stars and wondering what's out there.